The basic principle behind a vehicle equipped with in-wheel electric motors is simple. The internal combustion engine normally found under the hood is simply not necessary. It is replaced with at least two motors located in the hub of the wheels. These wheels contain not only the braking components, but also all of the functionality that was formerly performed by the engine, transmission, clutch, suspension, and other related parts. Although the concept is relatively simple in theory, in-wheel motors pose a number of questions about performance, function, and efficiency. So today, we'll take a look at all of these questions in this video. In recent years, we've seen some vehicle developers moving towards powertrain configurations, where the motor is mounted inside the wheel. That's an in-wheel motor system. We must admit, there is an impressive amount of new space available when the electric motors are integrated into the wheels. And sure, these so-called hub motors or in-wheel motors come with certain benefits, but they also create some challenges. In-wheel motors aren't new. At the beginning of the 20th century, Ferdinand Porsche's first hybrid vehicle used hub-mounted electric motors in each wheel. These motors power the wheel directly. There's no need for a gearbox or drive shaft. When using a reduction gearbox, the speed is reduced and the torque is multiplied. But with an in-wheel motor, there is no reduction. Wheel speed is equal to motor speed, so the required torque and power need to be delivered in a direct drive mode. In-wheel motors are directly exposed to dust, salt, water, and other fluids, but also to vibrations and shocks, which shortens their life expectancy. That's one of the main reasons Ford eventually decided to ditch the in-wheel motor concepts that they were working on for the new electric F-150 in 2008. The four in-wheel motors, also known as quad motor drive. These four motors deliver instant power and independently adjust torque at each wheel, for precise traction control in all conditions. Controlling power at the individual wheel enables torque vectoring. Don't know about torque vectoring? Don't worry, we discuss this in detail later on. For now, just remember its ability to neutralize oversteer and understeer to keep your vehicle steady and responsive through sharp maneuvers while off-roading and in the snow. Quad motors offer substantially better torque control than locking differentials, while also being instantly adjustable for on-road performance. Producing a vehicle that uses in-wheel electric motors is a process that's a lot more complex than just tearing out the engine and then cramming electric motors into the unused space inside the wheel. This type of electric motor is designed to work on hybrid vehicles, full battery-operated vehicles, and even fuel cell-powered electric vehicles. If you want to know more about how these electric vehicles works, then you can check out this video. The amount of power generated by these in-wheel motors can vary depending on the manufacturer and the size of the motor. The electric motor is installed inside the wheel and provides power to it directly, without the need for any transmission. The idea of installing the motor inside the wheel rim in an EV is a right choice. In this way, it can be ensured that the full output power of the motor is available at the wheel, without any mechanical transmission losses. The number of in-wheel motors a vehicle actually uses can be adjusted to meet the vehicle requirements. For instance, in most cases, two motors will supply sufficient power. If the EV is equipped with two motors in the front wheel axle, and thus the vehicle is a front-wheel drive, or in the rear wheel axle, and the vehicle is a rear-wheel drive. However, if you're talking about an all-wheel drive vehicle, either an off-road truck, or a performance car, obviously that would require to be equipped with an electric motor at each wheel. If you want to know more about front wheel, rear wheel, or all-wheel drive, then you can check out this video. Pure electric vehicles with in-wheel motors have a simpler design for both chassis and drivetrain, and they does not require any drive shaft, differential, and transmission. The combination of several in-wheel motors can put out more than 600 horsepower, and that they can receive their own energy while braking. But what about the instantaneous power that's sometimes required at the wheels? In other words, do these in-wheel electric motors provide enough torque for every application? After all, torque plays an important role in any automobile's response time and performance. In a vehicle equipped with in-wheel electric motors, there's plenty of torque available almost instantly. As a matter of fact, electric motors produce a high amount of torque, and since that force is transmitted directly to the wheel, very little is lost in the transfer. Each wheel can be equipped with sensors to determine how much torque is required at any given time. Similar systems exist in cars on the road now, but the response times are slightly slower due to the number of components involved and the more complex electrical communication pathways. Eliminating the engine makes it possible to add design and structural enhancements to a vehicle. To date, testing of the in-wheel electric motor system has been conducted by many automakers and technology companies, including the Venturi Corporation of Monaco, for use in its Volage concept vehicle, but questions of reliability, durability, and safety are difficult to report without widespread usage of the system. For traditional IC engine vehicle, the drivetrain system consists of conventional mechanical systems: the engine, the transmission, the exhaust system, the drive shaft, and the differential. In a conventional EV, the engine is replaced by an electric motor with inverter and a set of batteries installed at the back. In the case of EVs that use in-wheel motors, all the mechanical subsystems of the powertrain are eliminated and replaced with direct drive and wheel motors that do not need any drive shaft as they are connected to wheels. The only remaining system in this type of EVs is the conventional suspension. In-wheel motors can be used to deliver the torque vectoring strategies present in many high-performance vehicles. Torque vectoring is a technology that distributes an engine's power across the left and right side of the car. It is commonly employed in differential to vary the torque to each half shaft with an electronic system. With torque vectoring, one side of the wheel on the axle can go faster or slower than other. Torque vectoring, or perhaps more accurately termed torque biasing, is becoming more common on high-performance vehicles as a way to deliver improved cornering performance. Torque vectoring aims to improve steering response and handling through the distribution of torque between the wheels. By controlling the power across the axle more effectively, the car is able to corner with more grip and turn into a bend quicker. This is achieved by adding yaw moment onto the vehicle via active differential, brakes, or other mechanical solutions. There are plenty of ways to do torque vectoring. Most common is brake-based, where the inside wheel is slowed slightly by applying the brakes to one side of the vehicle, but not the other. That can be effective, but it means you're squandering power. Torque is being sent to the wheel, but you're artificially reducing its efficiency. Better is a torque vectoring differential. That has the same outcome, slowing the inside wheel, but it does so by actually reducing torque to that wheel. At the same time, the torque is increased to the outside wheel, meaning you're not wasting power overall. When you get to an EV, things can be even more interesting. Then you can have an electric motor dedicated to each wheel, each independently controlled. It can be faster and more responsive too, since it's adjusting torque electronically by how much power goes to each motor, rather than mechanically. In-wheel motors will always suffer more from no-load losses and part-load losses, because the motors can't be decoupled from the wheels. There is a trend of mounting more motors in a vehicle, and what we see, for example with the Porsche Taycan, is that the rear motors are decoupled from the wheels when cruising at highway speed to optimize the efficiency of the powertrain. This is very difficult to implement with in-wheel motors. They always rotate with the wheels, even when not used actively. Some companies claim that the efficiency with in-wheel motors is higher because there is no gearbox. Although a gearbox does always introduce a bit of inefficiency, the 1 or 2 speed gearboxes that are typically used for EVs are much more efficient than the complex multi-stage transmissions seen in combustion engine powertrains. We're looking at 1 or maybe 2% efficiency loss in the gearbox. This loss in efficiency is overcompensated by the fact that due to the gearbox, the electric motor can run on its most efficient operating area, resulting in an increase in vehicle range when compared to a direct drive system, depending on the use case and driving cycle. Some in-wheel motor designs offer regenerative braking as well. That means the system captures some of its own kinetic energy while braking and sends it back to charge the battery. Some hybrids, such as the Toyota Prius and Tesla Roadster, already incorporate this regenerative braking technology, which provides the automobiles with a longer driving range. One of the greatest advantages of in-wheel electric motors is the fact that the power goes straight from the motor directly to the wheel. Reducing the distance the power travels increases the efficiency of the motor. For instance, in city driving conditions, an internal combustion engine may only run at 20% efficiency, meaning that most of its energy is lost or wasted via the mechanical methods employed to get the power to the wheels. An in-wheel electric motor in the same environment is said to operate at about 90% efficiency. Porsche Engineering has developed a torque control system for a 4-motor electric vehicle drivetrain that lets electric SUVs handle with the agility of a sports car in even the most difficult conditions. Because of the much faster responsiveness of an electric motor, as compared to an IC engine, EV traction control systems can respond much more quickly. In an electric vehicle, the torque is purely electronically controlled, which works considerably faster than mechanical clutches. Every millisecond, intelligent software distributes the forces in such a way that the vehicle always behaves neutrally. But Porsche's solution is not just all-wheel drive. It utilizes 4 separate motors, one controlling each wheel. There are advantages and disadvantages to multiple motors. More motors increase cost and complexity, but eliminates the need for a drive shaft and gives more control. Wheel motors can also increase unsprung weight, which can have some negative effects on handling and ride quality. According to Chris Hilton, CTO of Protean Electric, in-wheel motors improve handling because the performance of each wheel can be finely controlled. They also lower the overall center of gravity and help to reduce weight and optimize weight distribution in the vehicle. Also, because in-wheel motors are located in the wheel, there are minimal losses in transmission of the torque to the road, as they are more efficient. This means greater vehicle range, or the same range from a smaller battery. Another firm working on in-wheel motors is Japan's Nidec, which announced its prototype in 2019. According to Nidec, the motor has a long list of advantages. For example, it produces less noise due to fewer moving parts. But perhaps the biggest advantage is space. Cars that use in-wheel motors don't need a motor compartment. Also, with the elimination of the drive shafts, the wheels can rotate freely. For example, it becomes possible to rotate the wheels 90 degrees and drive to the left or the right, or even rotate in place, instead of just driving forward or backward. This adds another dimension to how the car can move around and makes it easy to navigate tight spaces. The new Rivian R1T features one engine for each wheel. This quad-motor drivetrain enables the Rivian truck to handle like a sports sedan on-road and 4x4 off-road with ease. No other production truck offers this feature. The R1T EV will leave its competitors in the dust. In a straight line, the Rivian R1T is one of the world's fastest trucks. The Rivian truck's quad-motor drive system can put an incredible 800 horsepower to the wheels. On the proper tires, an R1T can accelerate from 0 to 60 miles per hour in 3 seconds. This reportedly makes the R1T the fastest truck in the world. The Rivian R1T electric truck is not the cheapest option on the market. But with quad-motor drive and algorithms to distribute torque instantly, both on-road and off, it is the most versatile electric truck on the market. The Rivian R1T will leave electric super trucks with 6-figure price tags struggling to catch up. In-wheel motors are easy to install and replace. They add flexibility, as they can be used to power rear or front-wheel drive, as well as all-wheel drive vehicles, without much change in drivetrain. They are compact in size, as the entire motor is inside the wheel. In-wheel motors provides high efficiency due to the lack of mechanical losses from transmission, differential, and drive shafts, and makes the car to run quieter. With electronic motor control, it is possible to fine-tune each in-wheel motor's torque, RPM, and even direction of spin. This means features such as ABS, traction control, and even cruise control could be handled more efficiently. The major challenge in-wheel motors face is the issue of unsprung weight. Unsprung weight is the mass of all components including the frame, motor, passengers, and body, that are not supported by a car's suspension. Unsprung weight includes wheels, tires, and brakes, and it travels up and down over any bumps and potholes as it tries to follow the contours of the road. And with hub motors being part of the vehicle's unsprung weight, they will feel the impact of every pothole, bump, and high-speed turn. They will be exposed to road dirt, mud, dust, water, and road salt that can reduce the longevity of the motors. In-wheel motors are expensive than a single motor mount on rear axle. So what do you think about these in-wheel motors? Are they good for the performance of electric vehicles? What are your thoughts on this? Tell me in the comments. That's it, thanks for watching. Make sure to subscribe to my channel with notification for more content like this.